Hi everyone, we're going to determine the points at which the graph of the function has a horizontal tangent line, and we're using the quotient rule. So the first thing we want to do is take the derivative of x. So that's going to be your denominator times the derivative of your numerator minus your numerator times the derivative of the denominator. And then you square your denominator and clean this up. So when you clean this up, you're going to get x squared minus 2x. This is 2x squared minus 2x minus x squared over x minus 1 squared. So that's going to give you x squared minus 2x over x minus 1 squared. So now we want to know about the horizontal tangent line. So we need to know where the derivative of f of x equals 0. And what I'm going to look at is my numerator on this one. I factor out an x, I get x minus 2. So if I just look at my numerator, I know I have x equals 0 and x equals 2, because that would be what makes my numerator 0. So the horizontal tangents are at 0, 0 and 2, 4. And all you're doing is you're plugging in, for example, 0, 0 is easy, but you plug in your 2 up here, f of 2, and that would give you 2 squared over 2 minus 1, so that would be 4 over 1, and that's what gives you the 4. You plug it back into your original equation. Okay, the next one I have is this one, and so we're going to take the derivative of x, or f, so it's going to be x squared plus 1, your denominator times the derivative of your numerator, minus x squared plus 1 times, times x squared times the derivative of the denominator, which is 2x, all over your denominator squared. So what we're going to get is 2x cubed plus 2x minus 2x cubed over your denominator squared. And that gives you 2x over x squared plus 1 squared. Now, on this one, we're going to set the numerator to be 0. So because we want f of x to equal 0, so we just set this to 0, and the denominator would cancel out if you cross-multiplied. So clearly when your y is 0, then x is also going to be 0. So it has one horizontal tangent at 0, 0. The next one is this one. So we're going to take the derivative using your quotient rule. So it's going to be x squared times 4, derivative of the numerator, minus your numerator times derivative of your denominator, all over x squared squared, which is going to be x to the 4th. Now, if you clean this up, you're going to get 4x squared minus 8x squared, and that's going to be plus 4x, all over x to the 4th. So, you clean that up, I think, let's see, you clean that up, you're going to get these two equal negative 4x squared. You divide everything by x to the 4th, or basically I'm just going to factor out 1x. So if I factor out 1x, I'm going to rewrite this. I'm going to put him first. So that'd be 4 minus 4x over x to the fourth. And then this x would cancel and you'd have x cubed. So our final derivative is going to be, in simplified terms, 4 minus 4x over x cubed. Now we want to know our horizontal tangents, so we're going to set our equation to 0. That means you're setting your numerator basically to 0. So 4 minus 4x equals 0. 4 equals 4x, so x equals 1. So when y is 0, x is 1. And f has a horizontal tangent. Well, when x is 1, sorry about that. So basically, when x is 1, right here, you have to plug that back into this equation. So you get 4 times 1 minus 2 over 1, and that's going to give you 2. So f has a horizontal tangent at 1, 2. And the last one we have is this one. So again, we're going to take the derivative, and we write down the denominator times the derivative of the numerator minus our numerator times the derivative of the denominator, all over x squared minus 7 squared. So we're going to clean this up, get x squared minus 7 minus 2x squared plus 8x. And all over your common denominator. And this is going to give you, let's see, we're going to get x squared minus 8x plus 7 over x squared minus 7 squared. Now it looks like I can factor this, so I'm going to rewrite this as x minus 7 times x minus 1 over x squared minus 7 squared. Now, I want to evaluate when this equals 0, or basically the derivative of x equals 0, which is what that is. And when you do that, you're going to get x is 1 and x is 7. So what we're going to do is evaluate f of 1 back into this equation and f of 7. So when you plug in the 1, you're going to get, let's see, 1/2. And when you plug in the 7, you're going to get 1 over 14. So I'm going to write my x and y. There's your x. And then my 7 and my 1 over 14. So f has horizontal tangents at these 2 points here. And that's all. Thank you and have a nice day. Bye-bye.